Hi, I'm Hassan, the lecturer here at the Institute of Medical Education, and today we're going to take a look at solutions to Section 3 of ACER's GAMSAT Green Booklet, Practice Test 1, specifically Unit 32, questions 99 to 101. And in this unit, we've been given an equation that's used to model the behavior of a fixed amount of gas, and we're assigned the task of determining the dimensions or units of B, A, and Z. So this unit is difficult. It's not, I mean, if you don't have a background in mathematics, it will be difficult, which is why, if you've seen the previous videos, I always push the idea, please, when you're working out, leave your units in there and leave them in the equations, because just because we know that, for example, mass, length, and time have a specific SI unit, the SI unit isn't the only way to represent these units. There are other ways to represent units, which is what we're going to find out through these questions coming up. You can't escape the mathematics in a GAMSAT. I love to teach that to students because if you can understand the mathematics, the arithmetic, and how to be logical and how to be systematic in your approach, you can move up from, let's say, the 10th percentile to the 5th to the top 1 percentile for Section 3. So it's why we always encourage students to learn how to manipulate equations and to derive them from first principles. So please practice that. Whenever you're doing equations for practice, take note of the units, not just the SI units, but what, for example, the units for force, or how you can rearrange the units for, say, pressure, which we'll go through in a second. So it's important to know, if we take a look at the, if we just take a quick look at the equation here. So what we see is, straight away, your eye should be glued to these. So what we've got is a unit of pressure times a unit of volume equals Z times time. So, this is temperature. So it's going to be temperature. So it's important to note that you can't add or subtract dissimilar units. So therefore, if we're taking a look here, if you're adding, say, pressure plus this section, this has to be in units of pressure then. Same goes here. If this is a volume and you're subtracting something from it, that means this has to be a unit of volume, because you can't add or subtract dissimilar units. So if we were trying to say, for example, P and V, you can't just do P minus V or P plus V, because they're two dissimilar units. So pressure and volume can't be added or subtracted. You have to multiply or divide, which means this is why A over V squared is going to be measured in units of pressure, and B is going to be measured in units of volume. That's one thing to note. So especially for question 99 and 100. Also note that meters is a unit of length, seconds is a unit of time, and Kelvin is a unit of temperature. Keep that in mind, because they do ask us here, consider the dimensions of A and B in the fundamental quantities of mass, length, and time. So we know that the base unit for measuring 2D area, so we know that it's going to be squared. So that's going to be squared. So let's say meters squared. But if we have, let's say, a 3D area like a cube, this is going to be, let's see if I can do this. I did that pretty well. So that's going to be measured as cubic meter. Sorry, 3 there. Also, pressure. We know that pressure equals force divided by area. And we know that force can be represented as mass times acceleration. So therefore, pressure can be represented as mass times acceleration divided by area. And finally, work. So this is going to be more relevant for question 101. Work equals force times displacement of an object. So it can be represented as W equals for F times D. And it's also measured in joules. So keep that in mind. Again, if you have this knowledge, this prerequisite knowledge of all of these units and all of the equations, you can answer questions like this if they come up in the GAMSAT. So let's just get our whiteboard out. Okay, exit ghost mode, get our whiteboard. So we'll just write the equation, sorry. Where did we go? So we've got P plus A on V squared, V minus B equals Z temperature. So let's take a look. It says the dimensions of B are, so remember what we said in the intro. If you're subtracting from volume, B has to be a volume. So that's the first piece of information we need to know. So it has to be the same units as volume. So according to the SI system, the base unit for measuring length in cubic meters is, say, 1 meter cubed equals 1 meter times 1 meter times 1 meter. And we know that meter represents a length. So L, which is a length. So we can see in our options available, we've got A and B are represented in length, whereas C and D are represented in mass, length, temperature. However, we know that volume is actually measured in a unit of length. So we know that. So is it going to be L cubed or is it going to be L to the power of 6? Well, we're making the assumption here that it's going to be, the gas here is going to be in a cubic system. I know ACER doesn't say that specifically in the question, but we're going to assume it's going to be a cubic system because the SI unit for measuring a length of, let's say, a system like this is going to be in cubic meters. So therefore, we know V has to represent, or V has to equal our length cubed. So let's say if it's going to be meters or centimeters or millimeters cubed, we don't know, but we know it's going to be in our length cubed. They should, I think the reason why ACER didn't say it explicitly, it's what the shape is of the, that the gas is going to be in. It's because if they did say it was a cube, you'd know straight away what the answer is for 99. But it's just assumed that if we're going to use a state to model the behavior of the fixed amount of gas, it will be in some sort of 3D structure because we are in a 3D world, if you want to put it that way. So if you're going to put it in a box, it's going to be a 3D structure. So the volume is going to be measured in L cubed. So therefore, the answer for A, 99, is going to be A. So if we just clear this here, and now we go to question 100. So we're asked now to find the dimensions of A. So remember, we have P plus, if we look at the left-hand side, A over V squared. So we know, therefore, it has to be, so A has to be in the units of pressure. So what are the units of pressure? So let's just figure out what the units of pressure are. So we know that pressure equals force over area. Don't forget that. So that's something, again, prerequisite knowledge. So force over area. We know that force also equals mass times acceleration. So mass times acceleration over area. Remember, we have to represent the answers because it says in the unit in the fundamental quantities of mass, length, and time. So area is going to be length. So we know that area is squared. So cubed is, area is squared. Yeah, cubed is going to be to the power of 3. Area is going to be to the power of 2. So it's going to be mass, so mass times acceleration over L squared because it's our area, which is in dimension squared. So now we know what the unit is of pressure. We can rewrite it now again so that we can get it in the correct units because they want us to use the fundamental qualities of mass, length, and time. So we've got acceleration. We have to show it in time. So we know that, or in length and time. So we know that if P equals, say, mass times acceleration over L squared, we know that it also equals mass. So acceleration equals meters per second. So it's going to be mass times meters over per second, so second squared times L squared. So we can rewrite this as therefore, so we want to show mass, so mass times our meters. Remember, our meters is our dimension, so it's going to be in length over our time, so T squared times our length, so it's going to be L squared. So therefore, the equation now we can rearrange this equation. So if we just, I guess, remove this L, so what we're left is with pressure, the units for pressure are going to be mass over temperature squared times length, or times the dimension. So the important thing to note is, remember what we said at the top, that the units for pressure are going to be exactly the same as the units for our A over V squared. So therefore, this equation, so our pressure that we derived, can also equal now A over V squared. So now let's rearrange this equation. So remember from question 99, we found out that our V squared, so if we remember what we had, our V minus B equals ZT, we know that our V is going to be in measurement of L cubed. So we know, therefore, we can rewrite this as P equals M over T squared L, which equals A over L to the power of 6, because it's squared. So 3 times 2 is 6. So therefore, now if we rearrange the equation, so times this by L6, L to the power of 6, times this by L to the power of 6, we're going to be left with ML6 over T squared L equals A. Just cross it off. Therefore, A is going to equal M over L5, L to the power 5 over T squared. So therefore, our answer, if we take a look at our options, so ML5 squared over T squared is going to be B. So 100, our answer for 100 is B. So now if we move on to the last question, so let's just clear the screen here. So we're told we want to find out the constant Z and how can it be expressed. So remember, if we take a look at our equation from the beginning, A over V squared, V minus B equals ZT. Remember, this is going to be unit of pressure, so it's going to be P. This is going to be in unit of volume, V equals ZT. So we can rearrange this then. This equation can be rearranged to Z equals PV over T. So remember that pressure, so from question 100, remember that our pressure equals, so pressure equals force over our area, which is L squared. So remember, force over area. And we know that our V from question 99 is going to be L cubed. So these are our previously known and derived questions. So therefore, we can substitute those into the equation and we get Z equals force times our length cubed. So P times V, remember? So force is going to be, our P equals force over L squared. So P, so let's do this. Sorry, let's do it this way. F, so force over L squared, times our volume, which is going to be L cubed, times our time. And if we recall, work, remember what we said in the intro, equals force times displacement of, or distance of displacement of our object. And we know that it's measured in joules, so it's going to be joules. And what do we have here? We have our force, so let's just cross this off. So we're going to be left with force times length over T. And we know that work is force times displacement of distance of displacement of our object. And we've got length here. So it's going to be, again, the distance of displacement. So therefore, we can represent this as work. So it's going to be Z is going to equal our, let's say, our work over our temperature. So we know that units of work is joules and the units of temperature are Kelvin. So therefore, Z equals joule per Kelvin. Or the way it's written there is joule Kelvin minus 1. So the answer for 101 has to be D. So that, look, it's obvious that that was not, if I just get the ghost mode here. So remember 99 is going to equal A, our 100 was going to equal, 100 is going to equal B, and our 101 is going to equal D. So I know this was definitely not straightforward. I also know that this sort of question is really going to be the question that differentiates, let's say, the distinctions from the high distinctions, or the top 10 percentile from the top 1 percentile. It requires a lot of prerequisite mathematical knowledge, units, equations, knowledge of SI units, and a lot of arithmetic manipulation, and a lot of systematic approach to these questions. But it doesn't mean you can't get it. You can get it if you just, again, the best advice I can give is every time you're writing out equations, leave the units in there and take note of the equations and the units that aren't SI units. Say, for example, for mass, or for force, or for acceleration, or for velocity. So take note of that, because if you do, it will make answering these questions a lot easier. Now, if you do have any more questions about this unit or any other mathematical type questions, you can post them in the comment section below, or you can contact us directly. We'd love to help. Thanks for your time. Bye now.